Section 4.7 is factoring binomials. So earlier in 4.3 to be exact, we talked about a squared minus b squared being a plus b, a minus b. Remember, this is difference of squares. So example 1 says 16x squared minus 9. Notice that there are only two terms, so we need two terms, which we do. That's a check. It needs to have a minus sign in between. That's another check. And the numbers need to be perfect squares. So we have three checks. When you have three checks, it's going to break down into a plus minus situation. So the first parenthesis is going to have a plus sign in between. The second one will have a minus sign. Notice that I put square root bars above the 16 and the 9 because we said they're perfect squares. Square root of 16 is a 4, so I'm going to write 4x. 4x. Square root of 9 is a 3, so I'm going to write a 3 and a 3. So we result in 4x plus 3 times 4x minus 3, and we are factored. When do we look at example 2, though? Let's write our things. We need to have two terms, minus sign, perfect squares. Okay, so we have 98c squared d minus 50d cubed. Okay, two terms, check. Minus sign, check. Perfect squares. Square root 98 is not a perfect number. I cannot take the square root of 98 evenly, and I cannot take the square root of 50 evenly. Also, the d here, in the first term, it's an exponent of 1, which is an odd power. The d cubed is an exponent of 3, which is an odd power. So they don't have anything in common. So first thing we need to pull out is a GCF now. So we're going to pull out a GCF. 98 and 50 are even, so I know that I can factor out a 2. 2c's, 1d, 3d's. They have a d in common. So my GCF is checked out. So now I become 2d on the outside. 98 divided by 2 is a 49. C squared, d's canceled, minus 50 divided by 2 is a 25. D squared because I reduced by 1. Now when we look at it, inside, 49 is a perfect square root. 25 is a perfect square root, so we have our missing part. So once we get to this point, draw two parentheses, 2d slides down, plus, minus. Square root of 49, that is a 7 with a C, 7 with a C. 25, that is 5 with a D, 5 with a D, and we are factored. In example 3, it says z to the 4th minus 81. So two terms, check. Minus sign, check. Perfect number, check. So we can break it down. So this breaks down into a plus minus situation, but there's a catch. Yes, we have a plus minus situation, but remember, the exponent is a power of 4 and you split them. So since it's a power of 4, you're going to write z squared, z squared. Square root of 81 is a 9 and a 9. Now when you get to this point, remember to verify that you have factored completely. Z squared plus 9. Two terms, check. Plus sign, I cannot continue. Two terms, check. Minus sign, I can continue. And then notice that here, it's a radical 9. I can take the square root of. So it breaks down further. So that breaks down into a plus minus situation. So I get z plus 3, z minus 3, and then z squared plus 9 breaks down. Example 4 says y cubed minus 6y squared minus 4y plus 24. So when we come to this problem, you notice that we have 4 terms. 4 terms talks about grouping. So in this one, we're going to do grouping by group. Notice that they all have y involved in the first 3 terms and then a plain number. So we're going to group the first 2 terms and the second 2 terms. In the first term, they both share y squared. In the second one, they both have a factor of 4. So that's what's going in front of the parentheses. So we have y squared, parentheses, minus 4, parentheses. So now we see y cubed divided by y squared. I have a y. Negative 6y squared, take out y squared. I have a minus 6. Now remember, we're dividing by -4, not +4. So -4y divided by -4 gives you +y. Positive 24 divided by -4 is a -6. Remember earlier from grouping, if the bubbles match, that is your first piece because that's your GCF, that's y minus 6. Your leftover in this instance is y squared minus 4. That goes in the second one. But before you stop, verify that you can't factor it further down. Y minus 6 is y minus 6 because the power is a 1. But y squared minus 4, we have two terms. We have a minus sign. Perfect number of the 4, which means this breaks down to a plus minus situation, plus minus. So we have y plus 2, y minus 2, and then y minus 6 slides down and we are factored. Example 5. It says x squared minus y squared minus 6y minus 9. Again, we have 4 terms. And if we were to group the first 2 terms and the second 2 terms, they have nothing in common to factor out. So this is an unorthodox grouping. We are not grouping the first 2 terms and the second 2 terms. We're going to group the first term by itself and the second 3 terms together. So I'm doing a single x squared and then y squared minus 6y minus 9 because I see a perfect trinomial here. So first thing, nothing factors out of the 1, x squared, that's just a 1. But I'm going to factor out a 1 out of the second one for right now. So we rewrite it as x squared, there's a 1. Minus 1 is coming out. And we get y squared plus 6y plus 9. So we're going to break this down further. So the 1 is just there to be a piece of the value. So we're not using it. So I'm writing x squared. But this one right here, y squared plus 6y plus 9, this is a perfect sum of squares. So it breaks down into a power of 2. Remember, square root of 9 is 3. Plus 9 in the middle, so I get y plus 3. So now I'm going to apply substitution method because I don't like the fact that I see x squared minus 1 times a bubble. So I'm going to use a variable. They've used x's and y's. First letter of the alphabet is an a, so a is going to represent y plus 3. So we become x squared minus now a squared because remember y plus 3 is our bubble. So I see x squared minus a squared. So here is difference of squares, 2 terms, minus sign, powers are even. So this breaks down into a plus minus situation, plus minus. So we see x plus a, x minus a, but remember a was not part of our problem. It was y plus 3, so we're going to bring y plus 3 back. So we see x plus y plus 3 in parentheses times x minus y plus 3 in parentheses. You can leave your answer in this format, but if you don't want the double parentheses, remember that this minus sign is being distributed into the second piece. The plus sign is being distributed into the second piece. So we become x plus y plus 3, x minus y minus 3. And there's your factored form. Okay, sum of cubes and difference of cubes. So these are special formulas. So sum of cubes says a cubed plus b cubed is written as a plus b times a squared minus ab plus b squared. This portion here, a squared minus ab plus b squared, looks similar to perfect square trinomials, but it's missing the 2 attachment. Difference of cubes, a cubed minus b cubed, breaks down to a minus b times a squared plus ab plus b squared. Looks kind of like the perfect sums, but it's missing the 2. Notice that the 2 formulas, if I'm a sum of cubes, I go plus and then minus plus. If I'm a difference of cubes, I go minus plus plus. The signs are opposite. The signs are opposite. So in example 6, it says 8x cubed minus 27. Remember, sum of cubes and difference of cubes are going to have 2 terms, kind of like difference of squares. Minus or plus in the middle in this instance, but their exponents are 3s. They're odd exponents raised to a power of 3. Now, in order to figure this out, first identify what's going to be the a and the b. So 8x cubed can be rewritten, that's why I'm putting parentheses power of 3, minus sign, parentheses power of 3. A number that I can multiply 3 times, that's what cube means, in a row that gives me 8. Well, that value is a 2. X multiplied 3 times in a row gives you x cubed. 27. A number multiplied 3 times in a row that gives you 27 is the number of 3. The reason I did this is so we can identify a and b. So 2x is going to represent a, 3 is going to represent b. We have an a cubed minus b cubed situation, which means the formula breaks down to a minus b times a squared plus ab plus b squared. So these patterns are going to determine what's going to go inside. So it goes a minus b. Well, a is 2x, b is 3, so my first parentheses is 2x minus 3, and I'm done with that part. The second one says it's a squared. Well, a is 2x. 2 squared is 4, x squared is x squared, so I'm going to write 4x squared. Plus sign, it says a times b. Well, a, 2x times 3, 2 times 3 is 6 with an x. There's my middle piece. Plus the b squared. Well, 3 squared is a 9, and you are finished. The sum and difference of cubes are basic patterns. You just need to plug them into the formula, and it gives you your answer. In example 7, it says 125t cubed plus 64z to the 6. So now, again, remember, you need to first raise them to a power of 3. A bubble, parentheses raised to a power of 3, plus sign, parentheses raised to a power of 3. Now, in the first one, a number multiplied 3 times in a row that gives you 125. That is 5. And they have a t. 64, a number multiplied 3 times in a row that gives you 64. That is 4. Now the z's in this instance. Notice that you had 6 in total, but the x1 is 3. In order to get a 3, you had to have a power of 2 inside, because 2 times 3 is 6. So now we identify our a. Our a value is 5t. Our b value is 4z. So we are in the form of a cubed plus b cubed. So using the formula, that becomes a plus b times a squared minus a times b plus b squared. So we're going to identify our pieces. A plus b, well, that's 5t plus 4z squared. Now it says a squared. Well, 5 squared is 25 with t to the power of 2, minus sign. It's a times b. Well, 5 times 4 is 20. That's my coefficient. T and z squared. So I'm going to write tz squared. Plus sign, it says b squared. Well, 4 squared is 16. But here it's z squared, and then I'm squaring that again. So I get z to the 4th. There is your expansion. Example 8, factor x to the 6 minus y to the 6. So they want us to factor this 2 ways. The first way is difference of squares, and the second way is difference of cubes. You result in 2 different answers. So they want you to go the route of difference of squares. You start by writing your problem, which is x to the 6 minus y to the 6. And we're going to raise it to a power of 2 because that's what difference of squares means. So it's a bubble raised to a power of 2 for both of them. In order for me to raise a power of 2 on the outside, I need to be an x cubed on the inside and then a y cubed on the inside. So remember, difference of squares, which is a squared minus b squared, that is a plus b, a minus b. So this breaks down into x cubed plus y cubed, x cubed minus y cubed. Now I notice that I result in a sum of cubes and a difference of cubes. So we see, remember that the a value, think of this as x cubed plus y cubed, x cubed minus y cubed. Using the patterns from before, remember, if we are cubes, a cubed plus b cubed, that is a plus b, a squared minus ab plus b squared. If we're a cubed minus b cubed, where a minus b, a squared plus ab plus b squared. So I've identified that a and b are both x and y for both of them, regardless. So here's our two situations, and all we're going to do is group them together. So I'm going to write x plus y, but there's a and b, x squared minus xy plus y squared. There's the first set. That's the x cubed plus y cubed. Now we're going to go to the x cubed minus y cubed. So we're going to write x minus y, then x squared plus xy plus y squared closed. There is our result. So notice how many parentheses we have. 1, 2, 3, 4. So difference of squares results in 4 terms. Now let's look at the difference of cubes. Difference of cubes says they want us to use a power of 3. So when we start out with x minus 6, y to the 6, exponent has to be a 3 on the outside. So I have to be x squared, y squared. Now, power of 3 means I see a cubed minus b cubed in this instance. So we have the pattern of x squared minus y squared, that's a minus b. Then x to the 4th plus x squared y squared plus y to the 4th. But the only thing we have to change is this right here. Here is a difference of squares. So this one breaks down into x plus y, x minus y, and the other one slides down. It does not have anything to break down to. And we are factored. So notice now, the first one, difference of squares, resulted in 4 terms. Difference of cubes results in 1, 2, 3 terms. Difference of cubes results in 3 terms. So that's a neat trick to remember, that if you're pressed for time and you're taking an SAT or taking a test and they want you to factor anything that's a power of 6 on the outside and they say difference of squares, you go with the option that has four terms in it. You're going to go with the option that has 4 terms. If it says difference of cubes, you look for the option that has 3 terms in it. Now, if there were 2, then you need to verify